Solving with back substitution is a different way of continuing after Gaussian elimination. So, back substitution, you want to perform Gaussian elimination, then rewrite the augmented matrices as equations. So remember that we originally write them from equations as augmented matrices. Now, once we finish the Gaussian elimination, we're going to write them back as equations and then solve that system with substitution. So, here we see 1, -4, 4, and yes, this is the same example as with the Gauss-Jordan elimination problem. We can put this in in row echelon form by taking -5 times R1, adding it to R2, and putting that in R2. So 1, -5, 4, 4, 0, 18, -18. Now, the claim is let's just write it as x minus 4 equals 4, and 18y equals -18. And this pair of equations is super easy to solve. We divide by 18 on both sides, y equals -1, and then sorry, that's supposed to be y. And then substitute back in there. So that would be x minus 4 times -1 equals 4. So x plus 4 equals 4, and x equals 0. So now we have our system 0, -1. So this is an alternate way of continuing after Gaussian elimination. So let's look at this system. -1, -3, -3, -16, 4, 2, -14, 1, -2, -1, -15. So now what we want to do is we want to turn this into row echelon form. And what we need to do in order to get into row echelon form is we need to cancel out, we need this, this, and this to all be 0. So I'm going to take 4 times the first row and add it to the second row. 4 times -3 is -12, plus that is -10. That's going to be -12. Oh, 4 times -16 is -64. Add -14 to that, and that becomes -78. Now we want to use this, multiply, or add row 1 to row 3. So what do we get? -1, -3, -3, -16, 0, -10, -12, -78. And this will be 0, -5, -4, -31. So now the last thing that we need to do is we need to get that to cancel out. So what I'm going to do is I'm going to take twice this, or -2 times the third row, add it to the second row. Again, this is all to put it in row echelon form. 0, 0. -2 times -4 is +8. Add that to -12 and we get -4. -2 times this is +62. Add that to -78 and we get -16. 0, -5, -4, -31. And now, one more step before we perform the back substitution. So all of this was Gaussian elimination so far. I'm switching row 2 and row 3. I should probably tell you that. 0, -5, -4, -31, 0, 0, -4, -16. So now we have performed the Gaussian elimination. Now we want to rewrite these as equations. The most interesting equation that we have here is -4 times z equals -16. So that gives us z equals 4. So that's the first piece. Now we can use that with the second equation. So it tells us -4 times 4, so -5y equals, add 16 to both sides and we get -15, so y equals 3. And now we can use that with our first equation, which was -x minus 3y minus 3z equals -16. -x minus 3 times 3 minus 3 times 4 equals -16. -x minus 9 minus 12 equals -16. -x minus 21 equals -16. -x equals 5, and x equals -5. So we have -5, 3, 4. Some people prefer this substitution and don't like the Gauss-Jordan elimination, but essentially what we would do instead with Gauss-Jordan elimination is use this plugging it back in through multiplication. But you can use your good old-fashioned substitution once the elimination has gotten you down to row echelon form. Thanks.